Hi, my name is Miriam Baranchik and I'm a junior biology major. My presentation today is on the physics of biology, specifically on tension at the cellular level. So what is an example of tension? An example of tension can be seen in this image where two puppies are playing tug of war with a piece of rope. They are exhibiting tension upon that rope. So what exactly is tension? Tension is a specific type of contact force that occurs when the force is being applied by a rope or a cable. On the left here, we see a box which is being supported by a surface. This box is pushing down with the weight of gravity, and the table is responding with a contact force which keeps that box from moving. We see another example of a contact force, but this time the example is looking specifically at the force of tension. This force of tension is being exerted by the force of the rope, which is pulling up on the box, which has a weight of gravity which pushes down. This box is being supported by the rope, which transfers a force across the distance. So what is tension specifically at the cellular level? This tension occurs when cells adhere closely to a bodily tissue. The cells are deformed in shape by the strength of the adhesion that occurs, and the cells generate a counterforce, just like in the box example, that results in tension between the cell and the tissue. So rather than a box and a string, which the string may be attached to a hand or another surface, instead, in the cell, you see a cell on one end of the rope and a tissue on the other end of the proverbial rope. Examples of cells that exhibit this type of tension include fibroblasts, smooth muscle cells, and endothelial cells. We will examine a few of these cells in more detail towards the end of this presentation. So what are the mechanisms of cellular tension? How does this cell specifically adhere to this tissue? So, the cell adheres to the tissue by a direct link between proteins, which you can see in this gray here, which connect to receptors on the tissue, in the pink triangle. These proteins then connect to stress fibers, which connect to microtubules. The microtubules then connect to the centrosome. The stress fibers and the microtubules are acting as the rope in this situation and exerting tension between tissue and the cell. This tension allows the cell to sense and respond to external forces which might be acting upon the cell. What is the function of cellular tension? Why is it important for cells? When cells closely adhere together and to other tissues, it acts as a seal in blood vessels or a filter, which prevents large particles from passing through. This occurs as a function of the tight bonding between cells and between cells and tissues. We also see another example of cellular tension in smooth muscle cells, which connect to connective tissue and help to control blood pressure in this way. These cellular tension, as we mentioned earlier, allows cells to appropriately respond to applied forces. A correct, appropriate response to an applied force is a decrease in cell tension as a way of maintaining tension in the tissue. This example is called tension homeostasis. So why is cellular tension important? Why should we study it? We study cellular tension as a way of better understanding the forces at work in biological organisms. The future potential for this concept could be used in medical processes such as stimulating bone growth and repair and accelerating the healing of damaged blood vessels. These would lead to great advances in the medical field. Here are my references. I hope you enjoyed the presentation. Thank you so much.